So we're here to investigate this big question of why the human brain evolved to be so big and complex. But first I want to talk about something really clever that a student asked me, which was, how do we know all this stuff? How can scientists tell what kind of brain an animal had that lived millions of years ago? And it's a great question because the consistency of the brain is like Jell-O. It does not make a good fossil.
So we have some fossils of really early nervous systems where you can just sort of trace the outline of either a nerve net or, in this case, a chain of connected ganglia in an ancestor of modern-day insects. This critter's about 500 million years old from the very beginning of the lives of animals on Earth. But until 2016, we had never found a fossil of an ancient brain. But an amateur collector was walking on the beach in England and he found a tiny pebble that he recognized was probably some kind of fossil material, and it turned out to be an itty-bitty chunk of dinosaur brain. Super exciting.
While we don't have brain fossils, what we do have to look at are fossilized skulls. And by examining skulls, scientists can infer things like brain volume, the blood supply to the brain, and other things that help them make educated guesses about what the brains of our ancestors were like. So take our study of Neanderthals, one of our extinct hominid cousins. Our examination of their skulls show that their brains were at least as large as ours, if not a little bit larger. And looking at their settlements, we can see that they lived in organized villages, they used sophisticated stone tools, they traded food and resources over a really large geographical area, and they even buried their dead with a sense of ceremony. We've found Neanderthal graves where the body is laid out in a particular way with treasured items all around it. We've even found a Neanderthal who was buried with a stone flute. So they had music.
Okay, you guys, I definitely looked up what it sounds like when you play the Neanderthal flute. I mean, we all want to know, right?
And anthropologists have concluded that there's really no way Neanderthals created a society with all of this complexity without also having language and the capacity for abstract thought. And that means a really sophisticated, human-like brain. Okay, so those are the tools scientists have used to trace this story that we're telling about the expansion of human cognitive capacity over these past couple million years. Let's turn our attention back to this big question of why it was that we grew these big brains. What was the survival advantage? So our brains are about 6 times larger compared to our body size than any other animal. And remember, last time we learned that the human brain is really greedy in terms of the calories it consumes, taking up about 1/5 of the resources that your body takes in one day. Our gigantic brains are also costly in another way. You almost never see wild animals dying in childbirth, but before modern medical intervention, the maternal death rate was as high as 1 in 4 or 1 in 5 in some societies. And it's our brains that are to blame. The big skull size that a human infant has compared with its body size is kind of incompatible with the hip shape we have to walk upright. So given the cost of this investment, there had to be intense evolutionary pressure on our ancestors to grow these big brains, or else evolution never would have taken that chance. So there were probably several factors that all contributed at once to a kind of perfect storm of conditions that set up Homo sapiens to evolve our high-powered brains. We know that a few million years ago, the climate in the area where humans were living was going through a really intense transition. And human beings managed not only to adapt to that climate change, but also to migrate to other areas and live in new environments. And that required a really high degree of dietary flexibility. And one of the key changes that took place right about this time, about 2.5 million years ago, when the human brain size started really growing explosively, was cooking. So it's around this time that we begin to see evidence of cut marks on animal bones that we can tell were left by stone tools and not by teeth, and char marks on food that's left behind in prehistoric garbage dumps. So why was cooking so significant in the course of human brain development? Well, it really has to do with one of the fundamental questions that each organism has to address, which is how it spends its energy budget. So the body of an animal that grazes, as our ancestors probably did before the advent of cooking, puts a huge amount of energy into digesting. Then the body doesn't have enough resources left over to invest in a complex nervous system. Essentially, animals can't really afford to have a giant gut and a giant brain at the same time. And grazing is also incredibly time-consuming. A chimp spends 6 hours a day chewing, which kind of sounds relaxing to me. So it was cooking and the use of tools to prepare food for cooking that made it much faster and easier for us to digest our food, freeing up energy for the body to invest in the nervous system. On the flip side, cooking must have required bigger brains. So think about what would have been involved. Your tribe or group would have needed to gain the knowledge of how to start and tend fires. You would have had to develop stone tools to cut and prepare the food for cooking. And you would have had to come up with some system for sharing food, sharing labor and chores, and cooperating around this new form of work. So with all this cultural and genetic evolution happening at once, it created kind of a positive snowball effect, a virtuous cycle that favored intelligence more and more intensely. Basically, once your social group started talking, cooperating, and cooking, any group that had better cooperation and language skills was much more likely to survive and pass on their genes. So intelligence spiraled in kind of a runaway effect. It was this combination of new modern human skills that allowed our species to colonize nearly every environment on Earth. At the same time, we were going farther north into colder climates than the Neanderthals could tolerate, and we were moving into dense forest, tropical jungles, and open grassland. And we were doing all this with fairly wimpy bodies. These sort of skinny, soft, defenseless bodies with no fur or scales or fangs or claws. It's really remarkable. If you take a look at animals that are native to the land north of the Arctic Circle, that harsh, snowy tundra, they all have these incredible physiological adaptations to the environment. So you see thick, oily fur, large stores of fat under the skin, white coloring to blend in with the snow. But if you look at human beings from tribes that are native to the same region, they don't have any of those physiological adaptations. They're the same species as those of us living here in tropical Southern California. So what is it that allowed them to survive and thrive in one of the most harsh and intense climates on Earth? It's culture. They have cultural knowledge of how to build dwellings that protect them from the cold, how to hunt and store their very limited sources of food, and a culture that's built a mechanism for sharing food, labor, and trading so that the group thrives as a whole. Ultimately, the human brain is really a machine for acquiring culture. It's really that adaptation that has allowed us to be so prolific and successful as a species. In the blink of an eye, from an evolutionary point of view, we've developed written language, mathematics, and all kinds of technologies that allow us to do stuff like sailing and agriculture and medicine and even space travel. So, what's the takeaway from all of this? I would say one of the core ideas of this class is that your brain isn't here to make you happy. Your brain evolved not to give you a pleasant life, but to keep you surviving under dangerous conditions. And in some ways, you could say that a lot of the challenges we face today really have to do with this struggle of having a Paleolithic brain in our modern world. So that ability to anticipate a new danger and plan for a problem and solve a problem that hasn't even happened yet is definitely what helped my ancestors survive a couple million years ago. But it's also what keeps me up at night worrying about the interest rate on my kids' college savings account. So this human brain that we have is definitely a superpower, but it can also be a bit of a curse.
Oh, I have a pretty good meme about this.
In a lot of ways, human beings are a bit over-attuned to danger and pretty prone to the kind of overthinking that leads to a lot of our mental suffering. So one of the things that I hope you get out of this course, as you get to know your own brain better and recognize how all of these beautifully evolved parts cooperate in a kind of hodgepodge of layers, is that you'll begin to figure out how to work with your mind's architecture and kind of work around some of the parts of our evolutionary past that aren't as useful to a modern human and live a life of more ease. After all, you're a survivor. You come from a long, unbroken chain of apes who made it.